Welcome back, ladies and gentlemen. We are finally going to move away from conversions. I mean, don't worry, we'll come back to them, but we're moving away for the moment. Page 27, you will see that there was something called a percent composition. So, percent composition, well, let's break down what that is. For each piece of a compound, it has a mass. The percent composition tells you how much of the total mass comes from each piece. It can be written as a formula. You see it in your notes here. Percent composition equals the mass of the element in the compound divided by the mass of the compound. So if I write it down, this is going to be the mass of X divided by the mass of all. And that will be the percent composition. Obviously times by 100 to make it a percentage. Now, that's kind of it. And by itself, this isn't super useful, but it will be useful in the next lesson where we talk about empirical and molecular formulas. But first, before we get there, we've got to practice this. So you'll see, it says here, a compound contains 22.1 grams of copper, 11.2 grams of sulfur, and 22.3 grams of oxygen. Why do we know this? Well, because a chemist probably took whatever the material was originally and put some chemistry to it, right? Did some chemical reaction of some form and separated out all the pieces. It's kind of like, say, right here we've got our chemical compound and we've got all the different elements inside. And what ended up happening was a chemist ended up doing some chemistry in order to take out all the elements and spread them out and look at them and go, I see, I've got a lot of this one, very, very little of that one, and only a tiny amount of the orange there. So maybe the amounts look something like that. So these masses, of course, were picked up on by a scale or something. So that's kind of how we figured that out. Now, the reason why this is useful, bit of foreshadowing, right? Empirical formula, molecular formula, what does that mean? This is how we figured out what chemicals were. Like, think about it, right? Up until now, we've been teaching you guys lithium chloride, one lithium, one chloride. And then we said it's because we're balancing charges, for example. Well, when we started, we didn't know that. The reason we knew there was one lithium and one chloride was because we did experiments and we collected information about how much lithium and how much chlorine there was. And we were like, oh, wow, there's the same amount of both. That's interesting. So this is kind of a bit of a historical quirk, the way that we figured things out. It's also not terribly hard. So let's take a look at what we got here. The example in your book has a little table, and it talks about the steps we can take. So first thing, determine the total mass of the sample or compound, and then step 2, determine the percent composition of each. So the little table ends up saying that you've got the element, you've got the molecular mass, which you hopefully are really good at, and you've got your percent composition, which is what I'm looking for at the end. Okay, so we've got 3 elements. We've got copper, we've got sulfur, and we've got oxygen. And we're going to get a total at the end. So the molecular mass for copper is normally 22.1. The molecular mass for sulfur is 11.2. And oxygen is 22.3. Oh, sorry, that's not the molecular mass. That's the mass that we found. My bad. I've got the wrong title on this. That is the mass that we found. So the last thing then is what is the total mass? Well, we add all of this up and we're going to get a total of 55.6 grams. So that's how much we had to begin with. So now what do we do? Well, as our equation says, the mass of whatever it is divided by the mass of all of it. So 22.1 grams over 55.6 grams. And that's going to give us a percentage. Now, I've worked it out here. It's giving us about 39.7%. So what that's telling us is that the copper is taking up about 40% of the mass. 40% of everything to do with this compound, its mass, comes from the copper. So that tells us how much copper there is. The next one down is just going to be 11.2 divided by the 55.6. And that's going to give us, I have here, 20%. The last one will be the 22.3 divided by the 55.6, and that will give us 40.1%. And if you add up all these percentages, you get 99.8%. It should be 100, so I must have rounded when I originally did these numbers. And that's kind of it, right? Like, that is sort of the basic level question. This particular chemist already took the chemical compound, broke it into pieces, massed out each piece separately, and now has to do merely the last step of saying what percentage each one makes of the total. But this one's an easy one because somebody already massed it for you. We just spent a whole bunch of time learning about moles. Guess what we're going to do? Yeah, we're going to do a bunch of moles. So take a look at the next example. It says there, find the percent composition of 1 mole of calcium carbonate. Now, because it's 1 mole and we don't get masses, we're just going to have to assume that we're dealing with molar masses. That's why I had molecular mass right there originally. A little mistake on my part. I'll have to fix it. So we're going to erase this board here of pretty much all the numbers, and we're going to talk about this new example. We've got only 1 mole of calcium carbonate. So we've got 1 mole of CaCO3. So what are the pieces that make up our molecule here? Well, we've obviously got calcium, we've got carbon, and we've got oxygen, right? Those are the different pieces of calcium carbonate. Well, now the mass. We don't have the mass of carbon, or calcium, for example, or carbon. It's not like somebody's done it for us already, but they're telling us that we've got 1 mole of the stuff. And we know how much 1 mole of calcium weighs, and how much 1 mole of carbon weighs, and how much 1 mole of oxygen weighs. So we look it up on our periodic table. We get out our trusty periodic table, we check what the molar mass is, or remember, the same number for the atomic mass. When we look it up, we should get that calcium is going to be 40.08 grams per mole. We get that carbon should be 12.01 grams per mole. And oxygen is going to be 16 grams per mole. But we have 3 of them. Now, if there are 3 in calcium carbonate, well, we've got to multiply by 3. So we take out our trusty calculator. We're going to times this by 3 here. And we end up finding that we're going to get 16 times 3 equals 48. So in total, this one's going to be 48 grams per mole of oxygen. So now that we have our 48 grams per mole of oxygen, we've got our 12.01 grams per mole of carbon, and our 40.08 grams per mole of calcium, we add all of this up. So we take out our trusty calculator again. We're going to take our 48 plus our 12.01 plus our 40.08 equals 100.09. So that is the total mass that we expect from this molecule, at least in terms of 1 mole of the stuff. Now, as we saw, we do our percent composition. So it's going to be 40.08 divided by 100.09, 12.01 divided by 100.09, 48 divided by 100.09. So let's get to it. 40.08 divided by 100.09 equals. So this should be 40%. The next one, 12.01 divided by 100.09 equals. This should be about 12%. And 48 divided by 100.09 equals. And this one here will be 48%. And in theory, 40 plus 48 plus 12 equals 100%. There we go. We've managed to acquire information about how much percentage each one is. So what this is telling us is that 12% of the mass of this thing is carbon. So there's not a lot of carbon. That's what it's saying. Whereas we've got a fair amount of oxygen and we've got just slightly less of the calcium. Now, of course, this doesn't take into account the fact that each one of these things has a different mass. So the fact they have different masses means that things are going to be a little bit different. So we need to take that into account, but that'll be, again, the next unit. Now, you guys will see the last question here. You've got an example. It's for dealing with carbon dioxide. I want you guys to give that one a try. You will also notice that on the next page, in page 28, you've got tons of practice on this, with answers, of course. Give them a shot, see what you can do. Next video, we will pick up, we will be doing empirical and molecular formulas. This is basically where we use this for something, okay? All right, I'm going to leave it there, guys. Cheers.